In this video, we'll be looking at the meaning of gears, gear ratio, the types of gears, and the uses of gears. A gear or gears are wheels fixed onto machines which make different parts move at different speed. A gear is defined as a wheel fixed onto a machine that allows different parts move at different speed. Gears are toothed mechanical transmission elements used to transfer motion and power between machine component parts. And gears operating in mated pairs, they mesh their teeth with the teeth of other gear, which prevents slippage during the transmission process. Each gear or toothed component is attached to a machine shaft or base. Therefore, when the driving gear is the smaller gear. You can see the picture there. The driving gear is the smaller gear. It is the gear that provides the initial rotational input. The driving gear is smaller and provides the initial rotational input. It rotates along its shaft component, while the bigger gear is called the driving gear. The bigger gear is called the driving gear. The gear or tooth component which is impacted by the driving gear is known as the driving gear, and is larger or bigger in size. Now it rotates along its shaft component. Depending on the design and construction of the gear pair, the transference of motion between the driving shaft and the driven shaft can result in a change of direction of rotation. Again, the driving gear is smaller in diameter and the number of teeth have the bigger one called the driving gear, while the driven gear is larger in size and has double that of number of teeth in the driving gear. While the gear ratio is defined as the ratio of the number of teeth on the driven and driving gear. Again, the gear ratio is defined as the ratio of the number of teeth on the driving and the driven gear. Additionally, if the gears are not of equal sizes, the machine or system where they are fixed experiences a mechanical advantage, which allows for a change in the output speed and torque. The torque means the force which causes an object to rotate. Again, the torque is the force which causes an object to rotate. Gears and their mechanical characteristics are widely employed or used throughout industries to transmit motion. I say again that gears are used to transmit motion in machines and power in a variety of mechanical devices. You can find them in clocks, in instrumentations, in equipment, and to reduce or increase speed and torque in a variety of motorized devices, including automobiles, motorcycles, and machines. Now, other design characteristics, including the construction materials, the gear shape, the tooth construction and design, and gear pair configuration, help to classify and categorize the different types of gears available. And each of these gears offer different behavior and advantages, but the requirement and specification demanded by a particular motion or power transmission determines the type of gear that is most suitable for use. Gears are available in a variety of designs, construction, and configurations to suit a wide range of industries and applications. And these various characteristics allows gear to be classified and categorized in several different ways, which include the shape, the gear tooth design, and gear configuration. Now, most type of gears, let's look at the shape now. Most types of gears are circular. Most types of gear are circular in terms of the shape. The gear teeth are arranged around a cylindrical gear body with a circular face. And these gears can feature, we also have other features of gears like triangular or square-shaped face gears. Now, device and system which employ circular gears experiences constancy in the gear ratio. Now, what's the gear ratio again? The ratio of the driven gear, the number of teeth in the driving and driven gear, gives us the gear ratio. The ratio of the output to the input is the gear ratio. It's expressed both for rotary speed and for torque. So the constancy of the gear ratio means that given the same input, the device or system constantly provides the same output speed and torque. On the other hand, devices and systems which employ non-circular gear experiences variable speed and torque ratios. Variable speed and torque enables non-circular gear to fulfill special irregular motion requirements. For the tooth design, gear teeth are also referred to as cogs. Again, I say again that gear teeth are also referred to as cogs. Cogs, C-O-G-S. Gear teeth are also referred to as cogs. Hence, why a gear is called by the old term cog wheel. In other words, you can also refer to a gear as a cog wheel. Please take note of this. Gear can also be referred to as a cog wheel. Why in the previous design and construction, there are several common designs and construction of gears that are available. Next, let's look at the types of gear and their common industrial applications. The types of gear and their common industrial application. We have the spur gear. The spur gear finds application in clocks, in pumps, in watering system, in household applications, in clothes washing machines, in power plants, material handling systems, airspace, and aircraft. They also find in railways and trains. That's the spur gear. Why? For the helical gears, same as spur gears, but with greater load and higher speed. So they can find application in automobiles, in railways, and also in trains. Then we have the beaver gear. The beaver gear finds application in pumps, in power plants, material handling systems, aerospace and aircraft, railway trains, and automobiles. Then we have the worm gear, which find application in instruments, in lifting and elevators, material handling systems, also in automobile steering wheels. While the rack and pinion gears find application in weighing scales, material handling, transfer systems, railway trains, and automobiles. So these are the different types of gears and their application. Again, the spur gear, helical gear, beaver gear, the worm gear, the rack and pinion gear are examples of categories or types of gears. The spur gear, helical gear, beaver gear, the worm, rack and pinion gears find application in different industries and machines. So what we're saying in summary in terms of use of gear is that gears are used to transmit the energy developed by engines to road wheels. Gears are used to transmit the energy developed by engines to road wheels, while a gear is used also to change the speed of a machine. Gear is also used to change the direction of movement. It can either be forward or backward in a mechanical device. So, in summary, we're saying that gears are wheels fixed onto machines which make different parts move at different speed. And gears have two tread edges and this make them to mesh or engage. Note that until gear mesh or engage, there will be no movement. Until gear mesh or engage, there will be no movement. And basically, there are two categories of gears. We have the driving gear and the driven gear. The driving gear is a gear closest to the power source and attached to the driving shaft that provides the initial rotational input, while the driven gear is a gear or tooth component attached to the driven shaft, which is impacted by the driving gear and exhibits the final output, while the gear ratio is a ratio between the output value to the input value. The gear ratio is a ratio between the output value to the input value, or it is a ratio of the number of teeth on the driving and driven gear. Gears find application in so many instruments, machines, bicycles, railways and trains, and also different material systems. And spur gear, helical gear, beaver gear, worm gear, rack and pinion gear are examples of the types of gears.